So I see everyone here has a full belly and are ready to take on engineering the Lakehouse system for the next 10 years of growth. So this session is going to be slightly different than what I planned in the beginning, because then I realized, with all the new data stack consolidations and everything that's taking place, maybe we should talk about what not to do. So we're actually going to focus on the things not to do. A little bit about myself. I have a thesis in machine learning anomaly detection in the space of cybersecurity. I'm originally from Israel, so I guess a lot of people are there doing cybersecurity, so that's not really a big thing. I am a proud author of the book Scaling Machine Learning with Spark. If you're interested, let me know. I know the Prophecy booth here are giving away ebooks. I believe they're still around, so if you're interested in an ebook copy, they're handing out free copies, so go ahead and check it out. I worked at multiple Fortune 500 companies, and also I did as a data scientist doing research. I also got to engage with projects in a lot of Fortune 500 companies and startups. And now I'm doing more strategy parts around data and AI, because this is the space to be at the moment, and it's always good to capture on the momentum. So something to take with you as you build your career. This is the book. If you're interested, there's a QR code available on Amazon. But if you're interested, really, go ahead and take the ebook from the booth. It's perfect. So for our 20 minutes together, we're going to talk about how not to build a data lakehouse system. So we'll start with CAP Theorem. You here ever heard about CAP Theorem in the past? Definitely not a new concept. Yes, I see Matt in the back. Awesome. Also a couple of our people. We're going to talk about what's going on when we're boiling the ocean, a little bit what's the system that we're building, Rube Goldberg machines, budgeting for complexity, and last but not least, thinking about managed capabilities and skill planning. Really, really critical for us as we're building things, especially when we're thinking about the future. So not many people raised their hand when I said CAP Theorem. So I'll go a little bit over it. So CAP Theorem is something that was proved. It's a theory that was proved in practice, and actually a lot of us are using it today. Essentially, it's designing distributed database. We have some limitations. We can either get consistency, full consistency. We can either two of the three, consistency, availability, and partition tolerance. So we cannot have all the three of them together. And I know that can be a little bit confusing, because we all want to have high available systems, highly consistent, and have a good partition tolerance among all of these things. But unfortunately, in real life, that doesn't really happen. And we have to make hard choices when we're designing our systems. And so when we're making these hard choices, we roughly have two different applications that we can choose from, two different distributed database or distributed file systems that we can choose from. One that have ACID with high rate of async updates. That means I am going fully on consistency. That's really important for me to have the updates in place, and I might be relaxing on things such as availability or partition tolerance, one of the two. So you can imagine if I have a web application and I'm running now a query, that query might, in my query, I'm kind of locking a lot of the rows in the database. Are you familiar with locking rows in database for read and write? Perfect. I'm locking a lot of the rows in my database because I want to make sure I am saving and I have my data consistent across different readers. So that means my system might get into a halt eventually. So something to bear in mind as you go through that. And the second one is fast analytics scan across large volumes of data. You can think about Spark. Spark is a more optimistic analytics engine. Have you ever, one of you know that Spark is a more optimistic engine? You never thought about it? OK, I'll explain. So Spark essentially, because of the distributed approach, it has stochastic mechanism built into it. We can miss some of the rows. We can miss some of the executors that are running. We can even have duplicate of the data itself because it's more stochastic. It's more optimistic in that approach. It goes over all the data, and if something failed, it's OK. It will rerun it. And during that rerun, because of the checkpoint mechanism and how the executor operates, it might be that we'll get duplication of the data. Now, for some systems, that's fine. right? We can have some duplications on the data as long as it's not a financial transaction and then someone is billing me twice. That's not so fun, right? So something to bear in mind, we have these two choices usually when we're working with CAP Theorem. But hey, we're engineers, and we want to overcome these challenges and really do something that is different and innovative. And so what do? We boil the ocean. We think through all different architectures, all different abstractions, all different levels in order to have all three in place. And we're seeing a lot of big cloud vendors now saying that they're offering all three, all CAP Theorem in one place. If you've been reading the latest updates from AWS S3, which is a distributed file system, they're saying, hey, you can get all three in place, including consistency, availability, fault tolerance. And the mechanism behind it is, yes, they have very deep pockets, for sure, much deeper than probably most of the companies in that space, unless our business is to build the cloud. And so they're able to build different systems that are more complex and also build in all the fault tolerance and all the caching mechanism. And yet, it's still not always 100%, especially on the consistency side, not always 100% consistent, unless, as users, we're willing to give up on availability. But, hey, it's eventually what we created are things like Lambda architecture. People here familiar with Lambda architecture? Yes, it's fun managing Lambda architecture, right? You have a bunch of clusters. They'll tell you that you start with one cluster, you have in Hadoop a couple of machines, but then you realize, oh, my Hadoop, now I have an HDFS cluster that I need to manage. Now I have a Spark cluster that I need to manage. Now I have Kafka Brokers cluster that I need to manage. And I never really went deep into Hive or Cassandra or all the good stuff that's coming, Zookeeper sometimes under the hood if we need that. So essentially, we landed on an architecture that gives us something that it's very close to kind of solving CAP Theorem, but introduced a lot of challenges in terms of how we actually make it operationalizing this thing. And so a lot of companies are kind of moving away now from the Lambda architecture into the medallion architecture. It's kind of like a shift left to all streaming capabilities. So if we're thinking about the medallion architecture, we have a lot of the joins and streams happening early on in the beginning, before the gold layer itself. Very different than the Lambda architecture, where we have the serving layer doing the joins just before we are serving it to users. And the speed layer at the bottom giving us the real-time view and combining all the information that we need. So definitely a slightly different approach than what exists today. And we continue to see that evolve, following up like very basic abstractions level. So we see it also in the machine learning LLM space, and I know it's the last day of the conference. You probably want to hear more about LLMs. I'm not going to talk more about LLMs. I'll just say a couple of more words. But we're seeing that we're continuing to boil the ocean around all these abstractions levels again and again, and now we're doing it for LLMs. So a lot of companies now are introducing better hardware. Yes, we need better hardware in some place. This is necessary, but we don't necessarily need a whole operation system for machine learning, a whole platform dedicated for machine learning, and so on. The architecture aspect is an interesting one, and I'm going to touch it soon in my slide around architectures for machine learning. And how it actually resembles a lot of what we have today in the original data pipeline, in the original data lakehouse, either if you're heavy on the data warehouse side or if you're heavy on the data lake side. But the architecture essentially kind of continues to be the same, and we can actually leverage a lot of the tools that already exist. And my friend here introduced me to a Ruby Goldberg machine. He's standing right there. And it was a really interesting session that he gave them when I looked into the slide. And I said, OK, this is like really interesting. So Ruby Goldberg machine's actually saying is, you can invent really, really complex things that do very simple things that you can solve easily just for the presence of it, just for the sake of it. So this is a really good example of the self-operating napkin, especially when you need the parrot and next to letter E, just so you can clean your face after you had lunch. So we can build all this. You can think about this like in the dupe system, where we're building all this amazing stuff, but at the end of the day, we're dealing with something that doesn't necessarily means we need all this complexity in place. Now, sometimes we do need, because it gives us specific capabilities, but not always. All right. But the thing is, when we're designing these systems, we don't always budget for complexity. Right? We have all this design architecture conversations. We're sitting down, we're bringing the best talent, the best architects, we're bringing all the engineers, but we never really think, oh, now I have this cluster and that cluster, and the interoperability between the different programming language, and I want to introduce Go, and I want to introduce Rust. And that actually creates a bit more complexity. And so when we're reaching out to our managers, what they're saying is like, oh, my project is running late, so how about we'll add more developers into it? But unfortunately, most of our managers are not doing it anymore because they're following this diagram of how do I become more cost efficient, how do I reduce waste? So now we are in the place where we actually, a lot of the managers, a lot of engineering management, executives, and so on wants to reduce waste. So they're refusing many of their requests that we might put out there in order to create these complex systems that doesn't necessarily produce the ROI for the company. So we're facing a lot of refuses, reduction in force, reduction in things that we want to build, reuse of what already exists. I got to speak with a lot of different customers around how they're going to embark on their machine learning journey now, and they actually realized that they can reuse a lot of what they did in the data space, the data pipelines, the analytics pipeline. So a lot of managers are now leaning into that space, how they can repurpose a lot of the things and how they can recycle, because the world has changed and we need to become more cost efficient. And this is a slide courtesy of Rising Wave. They were very kind to give me this slide. And one of the things I saw, I went over all the booths and I saw all the new technologies coming in. One of the things I saw is they're actually offering something that enables a layer that gives me more capabilities than what already exists today. And so this is a good example of how I can repurpose and reuse some basic concepts, basic ideas of distributed SQL database for streaming for multiple use case of applications, either if it's machine learning, either if it's a ride-sharing application, or anything that I need. It gives me that basic approach. Today, there's a huge conversation also on machine learning, like how do I serve it in real time? ChatGPT, essentially, at the end of the day, the APIs, you want to get it as fast as possible. It's not real time, it's near real time. We're all waiting to see the regenerate of everything that's happening there. But essentially, we want to have one layer that enables us to be more agile in the use case that we're presenting to customers to drive ROI. So this is one example. The other one that I wanted to show you is actually from A16Z. This is the architecture, what they offered for the emerging LLM App Stack. And I want all the data engineers here today, all the engineering management, all the people who are doing analytics, to really take a good look into the different bullets they put in place, and imagine that you're seeing now a conversation around data. So what has changed is what we're getting into the system. You can see the contextual data, you can see the prompt few shot examples of all that. But at the end of the day, what we have data pipelines, we have embedding models. You can think about as our transformers, right? The transformers from the classic ETL. Yes, we have some vector database. It could be that we need to introduce some more optimizations around vectors, although vectors were here before, they didn't really work well. We changed it to columnar. So we're kind of doing a back and forth, but hey, it might be that we'll need to, So we have the vector database, like I mentioned, we have the APIs, we have the plugins, but what I want you to really take away from this is many of these technologies, including specific LLM cache, and under that you see Redis and SQLite, right? We've seen it in data warehousing, we've seen it in data engineering, we're seeing that in streaming systems. What is actually being changed is how we're using them and how we're stacking the things together, how we're working with that. We're getting input of text. We're doing a couple of prompt engineering on top of that. But essentially, if you really look carefully onto that, it's kind of like the same system. So if you're thinking about how you're building things for the future, bear in mind how you're actually doing reusability of things. And last bullet point I have for you today is sometimes people forget to use managed services and kind of overestimate in-house knowledge. It's great that sometimes we want everyone to know everything and be on the same level of the latest updates in technology. But it creates a lot of challenges for us because every time there is something new, we have to reskill the people, bring in education, bring in a lot of different things where we can actually use some of the managed services in place that helps us stay up to date and also being updated for us. So something to bear in mind, and I have one slide that Prophecy gave me. Now there is a big boom on generative AI platform. So Prophecy have a generic, relatively generic platform to do low code for data engineering. And so what they did, they said, okay, now because there's such a huge similarity between data engineering and generative AI platform, actually a lot of our users can use that to create their in-house generative AI platform. So they said, okay, bring us your enterprise data, right? We're injecting data. They gave us the low-code approach, so we can config some stuff through code, but we actually can move some bullets around. And then we have the knowledge warehouse, and on top of it, there is some UI where I can run the queries and connect to things such as Slack, and so on. So I'm expanding the capabilities, leveraging what already exists. So this is just one example that I picked up from some of the booths, but again, you can kind of see the repeated pattern on that space. Just to sum it up, CAP Theorem has been proved. It's here. If you have very, very deep pockets like Amazon, Microsoft Cloud, and so on, you can work with that, but sometimes we're just overcomplicating things, so be mindful of that. As engineers, we have a tendency to boil the ocean. It's okay as long as we're sticking to ROI and impact that we're delivering. Good for us, for our career, good for our manager's career. Everyone is happy. Rube Goldberg machine, don't do it. Try to avoid it as much as possible. And don't forget that everything that we do, there's always an extra complexity, and there's always some skills that we need to develop. So plan for it. As individuals, as engineers, do some skill planning and make sure you continue to grow. And definitely use managed services because it can cut some cost and time. With that, thank you so much. You can find me on LinkedIn or Twitter. Happy to connect with everyone here. It was a pleasure.